Our next speaker is Mike Conway from NIEHS, and he's going to be talking about updates on iRODS Data Repository Service Adapter.
Hey everybody, I hope you're enjoying the conference. I've seen a lot of good things, and you'll see in the demo I'm talking about that there's a lot of raw materials, the HTTP, the extensible iCommands, the S3 that are very important to this project. So it's been very beneficial to see all this work. I've been very impressed so far. So we're at the National Institute of Environmental Health Sciences. Really, we're about computational toxicology. So we're looking at things out in the environment that we're putting out in the environment and what do they do to people. And so PFAS here in North Carolina, for example, those are the kind of things that we look at for health effects. Are there any Netflix Stranger Things fans out here? You guys like Stranger Things? Well, you guys know that the Duffer brothers went to Jordan High School up the road. So if you're a Stranger Things fan, if you look at a map around here, Jordan Lake, Cornwallis Road, Eno River, these are all places in Durham. And this building right here is where I work, or where NIEHS is, and this is reputed to be the model for the Hawkins lab. So that's just an interesting tidbit. That's the end of my presentation. You guys enjoy your conference. So we do have iRODS. I just did want to tell you, we do have iRODS as a core service. All our NGS data is stored there. We have some interesting things we're doing with that we've talked about in the past. But right now we're up to 20 million raw run data files and 328,000 process files, which I'm sure we're not breaking the lives records, but we are moving some data, moving the daters. And we have full metadata at the project and sample level, what sample, run with what technology, all the indexes, all that good stuff. This is for a talk I'm doing on Monday, so I just shoved this in here. But here's the things that we're facing, or our trends. I did want to say I am speaking for myself. I am not setting NIH policy. I'm just talking as a programmer and a developer. But things are becoming increasingly data-driven. We're talking a lot among the different parts of NIH about data sharing and federation, which for some of the people who've been here more than a few years, that raises the hair on the back of your neck, right? We're increasingly data-driven, multi-institutional collaborations, very important, hybrid cloud and on-prem computing. So that's both on-prem to the cloud as well as between different cloud providers. And this is where iRODS, I think, is in a real sweet spot. And my talk is really about sort of raising this and sort of bringing these things up into the more broader view for people who are outside of this particular sort of area of science. Heterogeneous data, institutional, specialized repositories, and generalist repositories, so data is spread everywhere. So some of this is about having a hub where you can bring all these data together and do computation. Also handling PHI and PII, maintaining privacy. Okay, another thing that's important is AI and machine learning. So we're doing a lot of systematic review where we're using AI, because a lot of the stuff that we're interested in is actually locked away in publications. So extracting meaning from publications, pathways, gene interactions, chemical effects. There's a project we're going to talk about on Monday up at NFS and SF. On ToxPipe, where we are looking like everybody else at ChatGPT in terms of being able to pull all these disparate data sources and make new inferences about computational tox. We are moving to the cloud ourselves. So we have a Quartz project Deep and I are working on. We're going to talk a little bit about Gen 3, but there's sort of an intersection between Gen 3 and the iRODS community that we are trying to foster as developers, because a lot of these standards are interesting. We're looking at the intersection of climate and health, and we're actually looking at wildfires, so go figure. But some of what we're talking about is our own attempts to figure out what NIH is doing and try to align ourselves with some of the NIH platforms and standards, and iRODS does have a part in this. We wanted to talk about these terms: data grid, data commons, data mesh. So this, I'm borrowing this from Bob Grossman, from the folks in Chicago who we're working with. They did a presentation on this, just so I'm lifting this right from their presentation, but they have this notion of data commons, which, for folks that worked on things like the data nets, the idea of you have curated data, cloud-based computing infrastructure, and then all the software application tools and services for managing, analyzing that data. So for folks that have seen Cyverse and DE, they've really sort of nailed this 10 years ago. But this notion of data mesh sounds a lot like federation. So data ecosystems, you have different computational platforms, commons, across different clouds, across different resources, along with this hybrid governance framework. So what we're going to talk about, the whole thing about this data repository service is really about this, this idea of the ecosystem, the mesh, different platforms. You have boundaries for authentication, authorization around data sources, but yet you're able to compute across all these platforms. So GA4GH, Global Alliance for Genomics and Health, it's really important for NIH. There's a notion of federated analysis that covers conceptually a lot of sub-projects within GA4GH. So I'm going to be talking about, you see the yellow boxes there, DRS for data repository service. And so I want to make sure we understand this as a piece of a larger stack and related to the context of what the other components do. And again, for folks who are doing this or who did the data nets or some of these other projects, to think about how these map onto concepts that, again, we were doing 10 years ago, which is like the hilarious part. We've had these conversations over and over again, right? So the whole idea is you have multiple cloud providers, AWS, Google, Azure, and you have this notion of an abstract way to access data in those clouds. So these in the GA4GH world are going to be things like FASTQ files. Okay, so how can we access those? And what we don't want to do is we don't want to be in Azure and suck data in from AWS and read it there and pay all these egress charges. So the whole notion is, instead of that, why don't we just take that task that's looking at that data, dispatch it to that cloud, go through the DRS interface, operate on that data, and again, try to most efficiently move, prevent the movement of data, and again, paying those egress charges. So you have these tasks that are being apportioned out to all these different clouds. You have these task runners, and those tasks are dispatched from a layer that is running a workflow, CWL, WDL, Nextflow, tools like that. So that's what genomics or omics processing, and a lot of it's driven by these workflows. Then you have a repository for tools, which think of those as CWL workflows containers. So best practices workflows. Has anybody seen DocStore? Yeah, so the notion of, if you go on DocStore and you look in the GA4GH area, what's really interesting is you can pick a workflow from DocStore and you'll see a button that says run on Anvil, run on Terra. So that's actually exercising the stack. So I write a CWL workflow, I obtain references to data via DRS and dispatch tasks out there, run my workflow, pull my results back, and then pay the bill. The other thing that's interesting is I put a gray box around AWS. I'm not picking on them, but the notion that each of these areas has a authentication and authorization boundary around it. So it's also about mediating access to all those resources. So this is all wrapped up. So what was missing there was on-prem data. And guess what can fit there? iRODS, right? So here's an example. You have an iRODS resource. It's an on-prem analog of what you just saw in the cloud. Okay, and the notion here is you can add an iRODS grid and take advantage of locality. So I could dispatch a workflow on AWS. It can reach over to an on-prem, dispatch a task, run it, or vice versa. So essentially adding iRODS as an on-prem representation of the same system. So this idea of this boundary here also is the descriptions of these data usage limitations. You mark up your data sets saying this is, with certain data restrictions, and then you can authenticate and present claims for these things and sort of act like a virtual DAC where you make access based on the data usage described on these data sets, as well as, I'm a researcher, you present claims, I'm a researcher, I'm at this institution, I'm looking at these kinds of, I'm looking at melanoma. So all these things can go into an access decision. The TERS is a task runner. Think of funnel or something like that. I know that's one of the test implementations, but also think about an iRODS resource and the ability to dispatch a container to run on a storage resource to task. And then DRS is simply a RESTful interface that maps iRODS data objects and collections to GUIDs, presents the interfaces for doing all this access resolution. So when you look at DRS, you're going to be like, well, that's just a couple REST methods. And so all this hand waving here is really to understand that it's not so much about implementing the dumb REST interface. It's about the context that then puts in iRODS data grid potentially in. It's not as easy as I'm describing it, but at least we've made some initial steps. So there's a GitHub repository out here now for this iRODS DERS interface. It does work. We've actually demonstrated it at GA4GH Connect. We just did a hackathon with their validation suite to make sure we're compliant. So there's some links here. We're at version 1.2 of DERS. We want to implement 1.3. And current work is, look at this, authentication via Keycloak, OAuth, OpenID Connect, and upgrading to the 1.3 spec. So we're kind of in the middle of working this. So if you go to that repo, I'm just kind of walking you through what this looks like. So there's a Docker, of course, test framework in there that starts the DERS implementation, which is really just a REST API, thin REST API. And there's of course, an iRODS instance that runs. And then there's also, we added a console, which would be a great candidate for this pluggable iCommands. So there's now this console, and look what it has. It's got ICD, init, ILS. I just have the things I need in there for people to exercise this. So the whole notion here is there's a command that will just generate fake data. And then there's like an IMake DRSB. So the notion is you go to an iRODS collection, you say you're a DRS bundle, and that's it. What happens is little AVU sugar and you're gold. That's all that happens. So it's very lightweight. So here I've got a collection. I say IMake DRSB. There's a GUID that's issued. So I mark it up with a GUID. There's like a checksum of checksums that's computed, just some cruft that happens in the background. So as part of the demo, I'm just showing this through Postman. What the whole notion is, you go to the REST API. Right now I have this implemented in the lightweight REST API where I can get a bearer token, but this would be a great candidate for, the OAuth work in the HTTP, which is what I was asking about. So now I have that bearer token, I can do things, and it's really this simple. This is their just implementing their the REST API. I'm just saying, give me DRS objects, and I hand it that GUID. It's hard to read, but basically you're getting back a JSON structure that says, here I'm a collection, and if you look in here, some of the things it's returning include just an array of contents, and this is telling you all the constituent items in the bundle with a reference URI. I can then take one of those data objects and see what's different. So I call and get the data object. There's some stuff that's added beyond the collection. So you see here, the important thing are these access methods. So now I'm looking at an actual FASTQ file. Here's the access method for that FASTQ file. And you see that I've added two access methods here. One is a file, which I'm giving it the iRODS URI. So that would require instrumentation on the runtime for it to be able to interpret those URIs if you wanted to use like a direct, iCommands. There's also an HTTPS, which again could be the REST API. You'll see right now those things are null, but you have a type of HTTPS and an access ID that's the iRODS REST. A couple of the other access methods are S3. Well, guess what? So that's a very important piece for this. And you can even use also Globus. Globus is also one of the access methods that is honored by DRS. What the notion here is I pick my access method, and you'll also notice I'm not really utilizing it, but there's a notion of a region. So that's really cloud centric. That would be like, US East 1, et cetera. But it could also be zone : resource, or, you can have locality on-prem down to the resource level, like if you want to go to a particular store. But the notion here then is I can then ask for the access based on that access ID. So here I'm going for that data object, and I've added some extra cruft that says, give me the access using the iRODS REST method. And what I get back then is another URL, which could be a URL into the iRODS REST API. In this case, it's my own. But you see that it's also adding an XAPI key, which is a ticket. So one of the other things that's really nice is the ticket capabilities, so that you can have more fine-grained control about the lifetime of these access URLs if you wanted to pass this to a workflow and other things. So there's some really nice hooks. So that's how DERS works. So once I have this, the notion is in a CWL workflow, I can dispatch a task. It can reference those data using these IDs. And so it's portable across cloud providers, but you could also do this completely on-prem. And the notion of locality is important to the cloud, but I would also argue that the notion of locality, especially in a federation or a widely distributed grid, is also very important. The other thing too is I want to stress this notion of passports. So this is what I was talking about in terms of the authentication and authorization infrastructure. So in GA4GH, there's something called DURI. I forget what the acronym stands for, DURI. It's like researcher identity. And parts of that specification include something called DUO, which is a data use ontology that can express using an OWL schema, sort of the limitations on the use of the data. And then there is this notion of passport. So I can go to a passport broker, I get a passport that can describe, again, my role, my linked identities, and you can carry that passport and present it at all these nodes, and access decisions can be made, again, cross-cloud, and you carry that identity for a distributed workflow. So the notion here is we've already demonstrated this. It does work. It's very lightweight. The maturation, it would be, again, to start absorbing the new HTTP client, the extensible iCommands for just the ability to create and manage these bundles. And then what's very key, again, for this would be the S3 storage interface. So iRODS, again, can mix across cloud, on-prem. And, the other interesting thing I would say about this is we've seen this before. It's a little frustrating because GA4GH narrowly scopes these standards to, genomics, things like that. But the patterns are widely applicable. So even if we're not, if we're in geology or some other science, it's really important, I think, to pay attention to the evolution of these specifications. I'm interested to see like what other analogs are out there right now, like GA4GH with these standardization efforts across the cloud providers, because I just don't know it. Yeah, I'm sort of out of that loop. But anyways, yeah, I'm rambling now, so I think I'm done with my presentation.
Do we have any questions for Mike?
Yay.
Yeah. So I guess here's one question. Where have you found in developing this to be the most challenging parts, the sharpest edges, and things that kind of require more thinking?
It really is these raw materials. It really is. Since this is so lightweight, the leap from this into production would not be that difficult. Mm-hmm. What is really difficult is where do you finally point it when you have that access URL that is production ready. So, this laying on top again of the C API and then that OAuth OpenID Connect piece. Because again, my next step here was to put Keycloak into this and start formalizing that a little bit. So yeah, that's really what it's about. And as we build these raw pieces that we're seeing, especially so much this UGM, I think it's going to enable it.
Nice. Yep. Sounds good.
Okay.
All right. Thanks, Mike. Oh, we do have a question. We do have one more question.
How this interacts with the RAS, the researcher authentication service, and do the two things need to work together or not?
We actually just had our initial exploratory discussion with the RAS people, Rebecca Rosen and those folks last week. The Chords portal that we're putting up, that I hate to say it looks an awful lot like HEAL. That's the first place that we're going to be utilizing RAS. But RAS is the NIH broker for passports. So I know that the passports are still at an early stage, but that is built into the RAS endeavor. So that's where we expect to see passports as a production facility.
All right. All right. Thanks.